Okay. You can all hear and see the screen, right?
Yeah.
Yes, sir.
So now we had done one thing. We had started doing expressions and units, and this was the last thing we started talking about. Kc, just a quick recap. That I told you that Kc is the equilibrium constant. It's the ratio of the products concentration and the reactant concentration. And I told you that the coefficient becomes, you write your products, you write your reactants, and the coefficient in the equation becomes the power. That was what Kc was. And I told you that Kc is only calculated for reactions that are already at equilibrium. We figured out how to write the expression, we figured out how to write the units, and yes, that's about it. So I'm just going to do one or two questions which I gave you, and let's talk about how to write the units and the expression for that one. For example, this one, the expression for Kc is going to be products concentration, which is going to be phosphorus, and O2 concentration has a square bracket. So in this reaction, I'm just assuming, I just made this up, so I'm just assuming that this is a reaction that's at equilibrium, and it's all going to be divided by the reactants. The reactant is P4O10, and the coefficient in the equation becomes the power. So over here you've got 4p, so it's going to be p to the power 4. The other one is 5O2, so that's O2 with the power 5, and P4O10 is 1, so that's your expression. And you'll be told to write the unit as well. And for units, I told you that for concentration, the unit is mole per dm cube, but take it as x. So x to the power 4 into x to the power 5, divide that by the concentration of P4O10, that's going to be x. So if you simplify, it becomes x to the power 8, and you can replace x with concentration, which is mole per dm cube, so it has a power of 8, and you can simplify that and it would become mole to the power 8, and dm would become minus 24. So that's going to be your expression and unit for Kc. Is this clear to everyone?
Yes.
So we're going to talk about the first type of questions that you're going to get about Kc. One is obviously the one that we just did, writing the expression and the units. And also remember, sometimes the unit is going to get cancelled out as well. So for example, the unit over here, there's not going to be any unit. The expression is going to be that you have Kc and the concentration of the products, which are H2, and you've got Cl2. Those are your products, and that's going to be divided by the reactant, which is HCl, but there are two of them, so it's going to be squared. And if I take try and find the unit and take mole per dm cube as x, it's going to be x into x, and it's going to be divided by x squared. All the x are going to get cancelled out. That means it has no units. So don't get worried. Sometimes it's not going to have any units. Sometimes it's going to, so every time the unit is going to be different. Every time the expression is going to be different. So question type 1 is that you're supposed to calculate the value of Kc. So once you have the expression, you just put in the values. But the question is not always straightforward. It's always like this. For example, they might tell you that initially, I mean, the question would be worded in this way. So they're going to tell you that initially 0.2 moles of, let's say, H2 and 0.2 moles of I2 are mixed together. are added to a container. So here's my eventually a reaction happens. So after several days, it was found that 0.15 moles of I2 were left. And this is at equilibrium. So here's what's happening. You have a container. So I have this container, and that container has H2 and I2. So these are my H2 and I2 molecules that I've added to the container initially. So there are a bunch of I2 molecules. So these over here are my I2 molecules. So that's what's happening right at the beginning. Zero point 0.2 moles of H2 and zero point 0.2 moles of I2 are added to the container. This is the equilibrium that's going to be established, that the H2 and I2 are going to react. And let's say they've given the reaction, they're going to react and they're going to produce 2HI. So the molecules, they start bumping into each other and they start reacting. So H2 and I2, they react. These H2 and I2, they react. So they all start reacting with each other, and they continue to react and they continue to form these H2 and I2 molecules. So HI molecules are produced. So these black molecules are your 2HI molecules. So reaction starts. So initially you had added H2 and I2, 0.2 moles and 0.2 moles both, right at the beginning. But what has happened is that the reaction started and they started forming HI. So what's going to happen is that the quantity of H2 and I2 is going to decrease. There's going to be lesser and lesser H2 and I2, and the quantity of HI would start to increase. Is this clear to everyone? Alicia, is this clear? Mariam, Mahad, is this clear?
Yes.
Yes.
And when enough HI is formed, eventually there would come a point when the reverse reaction would also start. Like when you have HI molecules, the HI molecules might start reacting with each other, and they would start forming H2 and I2 back again, and that's when an equilibrium is reached. So after several days, it was found that after several days an equilibrium is reached. Once an equilibrium is reached, so remember your particles are going to decrease. They're no longer going to remain 0.2 moles. They're going to be less than 0.2 moles at equilibrium. And the quantity of HI initially was 0, but now the container is going to have some HI, and then the forward reaction becomes equal to the backward reaction. When that happens, when equilibrium is reached, that's when the reactants concentration, the product concentration, it stops changing, because let's say every second one molecule of HI is produced, every second one molecule of HI changes back. So the net quantity of HI would kind of become constant. Uh, so how do you figure out the value of Kc in this case? What you're going to do is, every time when you get this question, you're going to make a table. You have the equation with you, that's your H2 reacting with your I2 molecules, and they are producing 2HI. Now listen to this carefully, because every time you have to make this table, the table would have, it's going to look something like this. And so here we've got our table. The table is going to have two rows. The first one has your initial moles. like, what did you do initially? What was the container? What did the container have? So it had 0.2 moles of H2 and it had 0.2 moles of I2. Okay, that's what you did. Like initially, right at the beginning, you added 0.2 moles of H2 and 0.2 moles of I2, and there was nothing, there was no HI present, right? Is this clear? France, is this clear? Nabila?
Yeah.
Yes, sir.
Okay. Now, that's the initial situation. And then forward reaction happened, backward happened, and then the reaction started, and the rate of forward reaction became equal to the rate of backward reaction. So that's your, then you have your equilibrium situation. See, I'm just going to write EQ, that just stands for equilibrium. Uh, just saving time here. So you have your equilibrium situation. Now, after several days, it was found that 0.15 moles of I2, so the situation would change. Once the reaction starts, the situation that's present in the container, that's going to change. The container is going to look different now. So it was found that at equilibrium, you have 0.15 moles of I2. So you got 0.15 moles of I2. That's your equilibrium situation. So how many moles of the other substances do you have at equilibrium? Remember, the Kc, in Kc, I need to use the concentration of the reactants and the products at equilibrium. So I want to know, I know one thing, that there is 0.15 moles of I2 at equilibrium, but I don't know how many moles of H2 are present at equilibrium and how many moles of HI are present at equilibrium. I know that HI must have been formed, but what exact quantity, right? So the way you're going to solve this is that you added 0.2 moles of I2 right at the beginning. Uh, After several days, you still have 0.15 moles. So how many moles are missing now? You started off with 0.2 moles, and after several days, when you open the container, you've got 0.15 moles. So that means 0.05 moles are missing, right? Where did those 0.05 moles go? That means they reacted. That means out of the 0.2 that you had added, 0.05 moles have taken part in the reaction and they've formed HI because the amount of moles of I2 has decreased. Initially, you added 0.2 moles, but now you've got 0.15 moles. So there's 0.05 moles that are missing. So they must have reacted. They must have reacted with H2 and they must have turned into HI. Is this point clear?
Yes.
TK, Ahmed, did you get this? Abdullah, is this clear?
Understood.
So, initially we added 0.2. At equilibrium, we've got 0.15 after several days. So 0.05 is gone. That must have reacted. So let's focus on this now. So if 0.05, sorry, 0.05, not 0.5. Okay, this is 0.05. They have reacted. So if 0.05 have reacted, how many HI would they have produced? 1 I2 produces. It's 1:2, right? So if you have 0.05 reacting, the amount of HI that's going to be produced is going to be twice that amount. So it's going to be 0.05 multiplied by 2. 1 I2 produces 2 HI. So 0.05 moles are reacting. So they're going to produce 0.05 times 2. So that means over here, it's going to be 0.1. 0.05 times 2 is 0.1. So we know that 0.1 moles, they got produced. Okay, they got produced. So initially you had 0 moles. Now 0.1 moles got produced. So at equilibrium, you're going to have how many moles? You're going to have 0.1 moles because initially you didn't have any, but now 0.1 got produced. So you're going to have 0.1 moles at equilibrium. And similarly, I2 is not going to react alone. Like I2 went missing, right? So it's going to react with H2. and the two react in 1:1. So if 0.05 moles is taking part in the reaction, so 1:1 means that 0.05 moles of H2 must have reacted as well. So they are missing as well. So out of the 0.2 moles that you added, 0.05 moles of H2 are also gone. So if you subtract, it's going to be 0.15 moles as well. That would be present at equilibrium. So is this clear? This example.
Sir,
Yes,
I
sir.
did not understand the 0.15 mode. Can you do that again?
Which one?
H2 one, like before I2.
No, you understood I2, right?
Yeah.
You didn't understand H2, right?
Yes.
Yeah, I'm just saying that the only information, I mean, the red is the only information that was provided to you in the question, right? You figured out all the other information yourself. So we knew that we added zero point 0.2 moles into this container, right? And 0.15 moles were still present at equilibrium. That means there's only 0.05 moles that's missing. Where did that 0.05 moles go? They took part in the reaction and they turned into HI, right? Is this part clear?
Yes.
So I2 is I2 is not going to react alone. Like I2 reacts with H2, right? So if 0.05 moles of I2 is reacting, so one I2 reacts with one H2. So 0.05 moles are reacting, 0.05 moles of H2 must have also reacted. Do you get the point?
Oh, okay.
So out of the 0.05 moles of, I mean, we know that 0.05 moles of I2 are reacting. But that also means that 0.05 moles of H2 must have reacted as well then, because I2 is not going to react alone. It needs H2 to react with it. So 0.05 moles of H2 would also react. So you started off with 0.2, 0.05 is gone, you're left with 0.15. TK, is this clear to everyone?
Yes.
TK, and remember, we're going to do a lot of questions like these, TK, so we're going to practice this a lot. And we're going to learn how to fill this table over and over again. So I'm just going to change everything now. So that's the first example, TK. And what I can do is I can just take the table and we can continue to practice on the same table. I mean, this is the table that's for this question. Let's continue to practice this, how to figure out the equilibrium moles. It's the same reaction. Now I'm going to change everything and we're going to do everything again. Take a same reaction, same concept, everything is the same. Except now, let's, because every time it's going to be the initial moles and the final equilibrium moles. Just one second, let me rub this off. So let's start again from scratch. Okay, we're going to continue doing this. Let's start again from scratch. Now, let's say the question is, you've got your, I think there was initial. So you've got your initial moles. There was a container, and the container, okay, let's have that container. So the container had, somebody added 0.1 moles of H2 initially into the container, and he added 0.3 moles of I2, and he even added HI into it. So he added 0.5 moles of HI as well, right? So these things were added into the container. Now, so all these molecules, H2 and I2 and these HI were initially, they were not at equilibrium. So they were reacted. They were added to the container. So obviously there's going to be a reaction. Some forward reaction might start, some backward reaction might start. Like if there's more forward reaction, the amount of HI would increase and the amount of I2 and H2 would decrease, right? Vice versa, if there's more backward reaction, then the amount of H2 and I2 would increase and the amount of HI would decrease. Eventually, after several days, of the reaction going forward and backward and forward and backward, and equilibrium was reached. The rate of forward became equal to the rate of backward. When that happens, the concentrations or the quantity of the reactants and the products, they stop changing. So we've reached equilibrium, and then he opens the container, right? The reaction is going forward and backward, but now at the same rate. And he found out that there is 0.5 moles of I2 present at equilibrium. Okay, when you open the container after several days, there's 0.5 moles of I2. So that, now we're going to fill the other table now. That's the information. The red one is the information that's given. So I'm going to change the marker, and we're now going to try and figure out what are the values in the other boxes. So I'm going to focus on this first. So I'm going to focus on this. 0.3 moles of I2 were initially added, and now you have 0.5 moles. So what has happened is that the quantity of I2 has increased. So there's an extra 0.2 moles. You've got more I2 now. That means 0.2 moles of extra I2 is now present. That means the reaction kind of went backwards. Like there was more backward reaction happening, so more I2 was actually produced. So more I2 got produced. Is this clear?
Yes.
TK, is this clear to everyone? Nabila, is this clear? Mahat?
Yes, sir.
Okay. So you've got more I2 now. That means reaction is going backward. 0.2 moles of extra I2 has been produced. So where did that 0.2 moles came from? They came from because some HI must have reacted. So if you want to produce an extra 0.2 moles of I2, according to 1:2, 0.4 moles of HI must have reacted. Like it's 2:1, so 0.4 would react to produce 0.2, right? So that means over here 0.4 must have reacted. So the quantity of HI would decrease. Like you started off with 0.5, and you now know that 0.4 of that has reacted. So how many moles are you left with? You're left with 0.1. Out of the 0.5, 0.1 are gone. They've reacted. So you're left with 0.1. So is this clear?
Yes.
Yes.
And the other thing is, like if 0.2 moles of I2 are getting produced, they're not going to be produced alone. Like if there's forward reaction happening and an extra 0.2 moles are getting produced, it's 1:1. They're going to be produced in the same ratio. Like if 0.2 are produced, 0.2 of H2 would also be produced. So there's going to be an extra 0.2 moles of H2 that's going to be produced as well. So that means that you initially had 0.1 and now 0.2 extra have been produced. So you've got 0.3 moles now at equilibrium. So these are your equilibrium moles. You can remember these are the equilibrium moles are the ones that you're going to use in your Kc expression. So is this clear?
Yes.
Mayim, is this clear? Aisha, Alicia.
Yes.
So once more, let's I'll change the equation later. Let's just practice on the same equation. This equation is kind of simpler because the ratio is kind of simpler. So let's do another one, and and this time we'll have my initial moles are so what are my initial moles? Like initially I added I didn't have I'm not going to write moles. So I had no H2, right? And I had 1.2 moles of I2 and I had 1.8 moles of HI. Okay, forget the moles, it's just taking up space. I said these were the moles that I added into the container. Now, as soon as I added, the reaction started. Some forward reaction happened, some backward reaction must have happened, and I reached equilibrium. And equilibrium, please just hold on 1 second. Let me tell this. I said sorry. So I have this thing going on. Okay, so I initially added these moles, right? And at equilibrium, I found out that I had 0.06 moles of uh, I had 0.06 moles of H2, right? So that means there's an extra 0.06 moles that got produced. So that means that during whatever happened in those several days, there must have been some backward reaction, and you had an extra 0.06 moles getting produced, right? So 0.06 moles they've been produced. And if 0.06 moles are produced, then it's 1:1. 0.06 moles of I2 must have been produced as well. So the quantity of I2 would also increase. You start off with 1.2, now there's an extra 0.06, so at equilibrium you're going to have 1.8 moles, right? Okay, is this clear?
Yes.
And if 0.06 moles are getting produced, it's 1:2. That means 1.2 over here must have reacted. It's 1:2. To produce 0.06, the amount of HI would be double that would react. So it's going to be 1.2 that are reacting. So that means they're gone. So out of the 1.8, 1.2 are gone, so you're left with 0.06. So is this clear?
Sir, isn't I2 supposed to be 1.26 produced, not 1.8?
Sorry, you're right. You're right. TK, you're right. 1.26. I added incorrectly. So that one is 1.26. Did I make any other mistake? I made this mistake as well. I mean, 0.06 produced, double, it's going to be 0.12 over here. So this one should be 0.12 that's going to react. So 0.12 has reacted. And you can do the math, like if, what's the math now? Out of the 1.8, 0.12 have reacted. So what do you get? If you subtract, that's going to be 1.68.
Yes.
So that's correctly done. I said, so we're going to keep on doing this. Let's do another one. Now I'm going to change the equation. I'm going to have a slightly an equation with different ratios now. We're going to do exactly the same thing. Okay, this is probably the only thing that's complicated in this. It's so let's do an equation which has slightly different ratios. It's N2 plus 3H2 in equilibrium with 2NH3. So if the reaction goes forward, the ratio is different, backward. So the ratios are not that simple. Let's construct the table. And initially, you're going to add moles in the container. So initially, you're going to add moles to the container. And just one second, let me. So, and you have, let me. So the first column is the initial. This last one is your equilibrium situation. So this one now. So again, exactly the same thing, except the ratios are kind of different. So I added 0.5 moles of N2 with, and I mixed it with 0.8 moles of H2, and I had no NH3. So this is what I put in the container. Immediately a reaction started. It started going in the, it wouldn't go in the forward direction initially, but it started going in the forward direction, started producing more NH3. The NH3 started breaking down to form N2 and H2. And let's assume that after several days, an equilibrium was reached, that the rate of forward reaction became equal to the rate of backward reaction. And then when I opened the container, I found out that I had uh, z- I had 0 point, just trying to make the ratio simpler. So I had 0.4 moles of NH3. Okay, uh, that's the situation, and that's the question. And you have to find the equilibrium moles of all the other substances. So what do you do now? Starting over here, you're starting. There was no NH3 in the container. There was absolutely nothing there. Now you have 0.4. That means that in those several days there was more forward reaction happening, and there was NH3 being produced, and 0.4 got produced. So 0.4 of NH3 got produced. So is this clear?
Yes.
Now, according to the ratio, if you want to produce 0.4, the ratio is 2:3. So if you want to produce 0.4, how much of H2 must have reacted? 2:3. So 0.4 would be ratio what? 0.6, I think. I mean, according to the ratio, 3 react to produce 2. So if you're producing 0.4, an extra 0.4 got produced, so 0.6 must have reacted. So here 0.6 have reacted. So out of the 0.8 that you added, 0.6 got, they took part in the reaction, they reacted, and you're left with just 0.2 at equilibrium. Is this clear?
Yes.
Yes.
And again, obviously, this is not going to react alone. N2 would react with it as well. So to produce 0.4, what's the ratio? 2 are produced when 1 N2 reacts. So it's going to be half of that, 2:1. So to produce 0.4, 0.2 of N2 must have reacted as well. So that means 0.2 of N2, they have also taken part in the reaction. They've reacted. So that means out of the 0.5 that you initially added, 0.2 are gone. They've taken part in the reaction. So you're left with 0.3 moles at equilibrium. So you finally found your equilibrium moles. So this is what's important. So is this clear?
Yes. Understood.
Yes, sir.
Let's try and do another one. I'm just going to uh, redo this. I'm going to fill the table again with different values now. Okay, try and solve it and tell me what your answers. I'm going to rub all of this. And I'm just going to fill it up with random values. So I had 0.2 moles of this. Initially, I had 0.8 moles of this, and I had 1.5 moles of this. And at equilibrium, I found out that I now have 1.1 moles of H2. So find the other moles. Like what is the situation at equilibrium? So that's your question. Take it, try and solve this one. Okay. So send me the answers. I'll wait for the answers. So let's continue tomorrow then. Okay, everyone. Take care.
Allah
Hafiz.
Hafiz.
Okay, thank you.
Thank you.
Hafiz.
Sir,
Yes.
sir, actually मैंने आपसे बात करनी थी that like I almost missed a month, so like मैंने आपसे पहले भी WhatsApp पे बात तो की थी, so like
हाँ
I'm not getting this topic right now, तो हमने new topic अब start करने क्योंकि ये मैं अभी in between join किया, तो like I'm not getting this.
नहीं, कौन सा ये वाला पार्ट? नहीं, ये पार्ट एक तो पहली चीज ना, ये जो है ना, ये इसमें तुमने कुछ भी मिस नहीं किया हुआ, ठीक है?
अच्छा
तो वो एक्स्ट्रा क्लास लेके मैं समझा देता हूँ, ठीक है?
अच्छा अच्छा ना, तो बाकी आप कैसे like in अक्टूबर जब नया सेशन स्टार्ट होगा तब करूँगा मैं कवर,
हाँ,
जो like मैंने मिस कर दी.
हाँ, उसका इससे कोई ताल्लुक नहीं है.
अच्छा अच्छा चलिए सर, ठीक है, थैंक यू.
इसका मैं एक्स्ट्रा वो करके ना समझा दूंगा. ये क्योंकि वो तुम्हें दिमाग में ऐसा लग रहा है कि तुमने ना कोई मिस किया हुआ है, तो तुम्हें शायद इसलिए नहीं समझ आ रहा. तो वो
यस
अभी क्वेश्चन पूछो, ठीक है? वो फिर मैं समझा दूंगा, ठीक है?
ओके सर, थैंक यू सो मच.
ओके ओके.
अल्लाह हाफ़िज़.